Hey everyone, welcome to the 17th episode of the Coffee with Cosmos DB series. If you have missed to join the recording last time, you can watch the recording offline in the playlist that we have created. If you would like to know more about a particular feature or a topic, please ask in the chat so that we can take it up and discuss in the upcoming sessions. If you're joining this session for the first time, this series is all about sharing the knowledge on Cosmos DB by the experts to the community. So please make sure to subscribe the channel and share with the community members who are looking to learn more about Azure Cosmos DB. If you are interested to present or have any feedback, reach out to me. And thanks for all the feedback so far. Today we have an interesting topic, which is fundamentals of Cosmos DB. We will talk about consistency, and we have a interesting guest as well. Let me add him to the stage. Hi, Faiz.
Hi Sajid. Hi.
How are you doing?
How are you? I'm good. Sajid, how are you doing?
Yep, doing well. So, yeah, as I mentioned, FaZe is one of the cloud solution architect working closely with our top customers. Why don't you go ahead and introduce yourself?
Sure. Thanks, Sajid, first of all, for inviting me on this session today, right? So, myself, as I am a senior cloud solution architect, and I'm basically helping our large, RCG customers, right? When I say RCG, retail and consumer good customers, right? Mostly in the data and AI space. And I work with a lot of application teams, right, helping them in using Cosmos DB, right, in a highly efficient manner, right, so they are able to get the best out of it, right. Uh, and in terms of the session today, right, so a lot of application teams, right, so uh, whenever they are starting a new project, right, or whenever they are like thinking of making some changes, right, so consistency, what consistency to be used, right, that's like one of the key thing, right. So today I would take this opportunity, right, and I would basically talk a bit about the consistency. I hope we can start from here, right, Sajid?
Yep,
You're good,
go
right?
ahead. Yep.
Yeah. So today, right? So what I'm gonna do is like I'll be basically covering the consistency models, right? So what are the different models that are supported? And then I would also talk about the session tokens, right? And what role they play, right? Overall, how the quorum read and write happens. And then I will also talk about few scenarios, right, where we typically people have a lot of confusions and I mean they have a lot of queries around, right? So mostly to do with session consistency and how sessions can be used, right? So maybe I'll just cover few scenarios there. So quickly diving in, right? So as we all know, right, that Cosmos DB is a distributed database, right? Where and if I just talk about the backend infrastructure, right? So we have a concept of physical partitions, and this physical partitions they have their own set of replicas, right? So whenever I'm writing any data, right, to a collection, so that data may get stored on a physical partition, and then it will also get replicated to three other copies, right? So with this distributed database, a lot of emphasis is on the replication, right? And that will basically help you derive the high availability and low latency factor, right? And then we have this five consistency models, right? Right from, so the strongest being the strong, right? And then weakest being the eventual, right? And then we have this five consistency model, which basically the application teams, right, they can use, right, based on their needs, right? So, for example, there is an application team, right, who cannot compromise on any data loss, right? So, for them, there will be a certain consistency model that they'll use, right? So we're gonna talk over that, right? But overall, there are like this five consistency models, like strong, bounded staleness. We have session consistency, we have consistency prefix, and then we have eventual. And each of them, as I said, right, so based on the use case, this will differ, right, as to what they want to use. And one more thing is this, right, that whenever the teams are basically creating this accounts, right, whenever they provision Cosmos accounts, so they basically set a consistency model, right, at the account level, which, let's say, for example, it is default is session, right, or someone will set strong, but then they can basically override these values, right, based on their, they can relax those values whenever they want to, whenever they're performing some request operations, right? So that is also a possibility. But this is like something that is provisioned whenever account is created. So starting with strong over here, right? So what is strong? Strong is the strongest consistency level that we have, right? And it basically offers a linearizability guarantee, right? So what that really means is that uh, the data might be distributed across different machines, right? Or the operations could go to different machines, right? But it will be executed, all these operations will be executed in such a manner, right, that you will feel that all of that is, getting executed on a single machine, and you will always get to see, a consistent or up-to-date data. It's strong. So that's the beauty of strong. You would never see, any stale reads, right, from this consistency. You'll always get up-to-date data. But and the RPO, right? So when I say RPO is like recovery point objective is like zero, right? Because whenever using strong consistency, whenever you are actually writing the data, right? So that data will get replicated to multiple regions, right? So and with that, right? With that, what really also happens is that your write latency will literally go up a bit. So whenever you're thinking about using strong consistency, just keep in mind, right, that with strong consistency, you will end up, writing across regions, and that will basically shoot up your overall write latency. And at times, you might also, since you are actually uh, going for a consistent data, you might compromise on availability as well. Because if your data, if one of your regions is not available, right, so the data will not get replicated, and then you might end up compromising on the availability. But then your data will always be there, right? So you'll not lose your data. So this is like a consistency model that can basically be used for teams who really don't want to lose any data, right? And 100% data guarantee. So that's the strong consistency. Going
There's a
to
question on the
yeah.
chat. Let me take it up. Are pre-request consistency level? Oh, sorry, per request consistency level supported?
Yes, they are supported, right? So the way that will work is this, right? As I said, right? So whenever you basically provision account, and imagine that your provision you're using strong, right? So by default, it will be strong. But then let's assume that I want to read a data with the eventual consistency. So whenever I'm creating a the read request, I can specify that I want to use the eventual consistency for this. So that way you can still do that. And
Okay,
that
this
and
is
the
at the
read,
SDK level, is it?
sorry.
This is at
As
the
at the
SDK
SDK
level.
level,
Okay,
at the SDK level, right? So that you can do very well, do it, right?
all right,
And
thanks.
and one more important thing is this, right? That even though you may have used, right, at the SDK level, relaxed it, right, but that will only be applicable for read operations, not for write operations. So write would always be honored, right, with whatever default that you have configured at the account level.
Okay,
So that is
got
a
it.
very important consideration.
Thanks.
Yeah. Coming to the second one, right? So the second one is basically the bounded staleness. Is my slide visible?
Yeah, yeah,
There.
can see.
Yeah, yeah. All right. The second one is the bounded staleness, right? So the bounded staleness, I would say, is as good as strong, but then here you have a little bit of liberty, right, where you can specify the staleness window. And that staleness window could be in two ways, right? So you can either say, right, that I'm okay with being behind, right, by n number of operations, right, or I'm fine with 5 seconds of old data. So basically, you can configure that whenever you are creating your account. You can configure that, and based on that, this will be respected, right? But the only thing is this, right? That this is as good as session consistency. Sorry, the strong consistency, but then there's still a little bit of window, right, where you'll still see, stale data, right? So, for example, if you have a multi-region setup, right, it could very well happen, right, that you might write to a region A, and when you're trying to read from a region B, the replication may not have happened, right? And you can still see some stale data. But then when the time arrives, right, so the backend will basically throttle and make sure, right, the data is replicated. So that is something which will happen on our backend. But still, there's a chance of stale data. Plus, when we talk about the quorum rights, right? So in case of a strong, what we had seen was that the data was getting replicated across region. In case of bounded staleness, the data gets replicated only at a local region level, and then the asynchronous replication kicks in. So that way, the latency would be still be a lot better compared to strong, right? And this could be a very good candidate, right, where you are having a single, single write setup, right, and where you have multiple, read regions, and you can very well get a strong consistency, right? If you are basically, dealing in a single region. So ideal, right, in a way. And when it comes down to reading, right? So you will always your reads, right, will basically be correlated against your two replications. So for example, let's assume if you have stored a data document, maybe, in a document A, right? Maybe on a physical partition P, right? And on our backend, it will get replicated to maybe, three machines, right? So whenever you try to read a document, so it will the our SDK will reach out to two replicas, try to correlate the data, and send a response back, right? So that way, just to make sure that you're getting always getting consistent data or up to date information. So, all right, moving on to session consistency, right? So, with session consistency, what you really get is basically um if you are right within a session, right? If you're using a single client session, right? So you're all it will always honor, right? Your read your rights and write follow read guarantees, right? So that will always be there, right? So what that really means is that assuming that you have a single client, right, and you basically uh, update or write something to using that client, and whenever you try to read from that same client, it's guaranteed, right, that you're going to see the latest data out of it. But the moment you basically switch between this client side of the sessions, that guarantee is gone away. Okay, so that's the beauty of session consistency. And in case of session consistency, you can also see eventual reads, right? What that really means is that in case if the session tokens are not used, right, you could see unordered reads, right, coming in, which we'll talk, right, when I'll be specifically covering this. I'll be going a little deep dive on this, right? And I'll talk about different scenarios. But then with session without session tokens, there are chances, right, that you could see eventual reads happening. And then we have basically consistent prefix where you'll always see this is very good, right, for high throughput, and you'll always see ordered writes and ordered reads. The order would not, you'll never see unordered reads, which is the case with eventual consistency. And if I also talk about the kind of distribution that we have on our backend, right? So if you look at the right hand side, there's a pie chart, right? And if you look at this blue line, right? So that's the session. So we have close about 78% of our accounts, right, which are using session consistency, and just about 9% of the accounts which are using bounded staleness. And then followed by that, we have strong consistency, and then eventual, and then consistency prefix. So that's like a distribution of accounts, right, by the consistency model. Yeah. So also to explain, right, this consistency models, right, with some example, right, a baseball example, right, and this is like from our blog post, right, by Doug, right. So just to understand, right, that how this will typically work, right. So for example, you we have a baseball game, right, and then assuming that we have configured a high, strong consistency on the account, and now we are relaxing, right. So who's based on the user profile, right, they will just kind of customize, right, their or they'll just relax, right, their consistency models, right, and they'll just try to get the score. So here we have a baseball game, and then we have a visitor teams and we have a home team. So the score of visitors, so they have played close about 7 innings, and the score of visitors is like 0-0, 1-0, 1-0-0, and then the home team is like 1-0, 1-1, 0-2, 0-2, right? And the final scores is like 2 and 5. So imagine, right, someone who wants to basically, read this data, right? using strong consistency. So they are always going to see 2 and 5, right? So from this, right, let's assume an umpire, right, would always want to see a strongly consistent data, right? So they will not want to see something like 0001, right, or a stale data, right, because they'll not be able to make that judgment then, right? So for them, as a user, right, as an umpire, for them it is very important. Coming down to bounded staleness, there you will basically define the staleness window. So imagine the staleness window over here is inning, right? So an inning could take 15 minutes, and that staleness window is maybe 15 minutes. So in that case, if you see, right, so at one point of time, right, the scores were like visitors were 2, and then the home was 3, right? Or it could have been 2-4 or 2-5, right? So that's the bounded staleness, right? And maybe someone as a persona of a sports commentator, right, or someone who is writing the commentary, right, for them this is they're okay, right, with the lack of maybe a inning or so, right. For them this is the best way of uh, consistency, right? And then there could be, and if I go with the session, right? So imagine someone who is basically using the same session, they will basically see 2 and 5. But someone who is not using session, right? They can see any arbitrary, values, right? Which will be an eventual rate. So it will be a permutation and combination, like 0 1 0 0 0 1 1 0 0 0 2, right? So if you can see the all the permutation combinations, they get to see, right, with session without session tokens. And for this, right, a scorekeeper, right, can basically be a good example there, right? So whoever is maintaining the scores, right? So for them, this is the best example. Consistency prefix, right, is again ordered reads. So you will always get in a certain order like 00 or 01s, right, and 25. Because whatever value that has been written, you will never see any older data there, right? So that order will be maintained. And with eventual, that order is not guaranteed, as I said, right? So you can see any order of data. And this could be a good example, right, for someone, after the match is done, after a day or two, right, he wants to go back, right, or he or she wants to go back and see, right, what the score is, what happened in the match. So for them, eventually is good, right? They don't really worry, right, what's happening, right? So that's a way of understanding how you can specify this as an account level and how you can customize it based on your requirement, right? So even in a project, right, whenever you're creating a project, right, so you can still have a stronger consistency, but depending on your downstream application, you can still very much customize it, right, based on your use case. Okay, so I'll move on to the next one, right? So coming down here, right? So here we have something called as session tokens, right? So so what is session token, right? So session token is something, right? So whenever you're basically as a client, right, from a SDK, right? So whenever you are actually performing any sort of a operation, right? So let's assume I create a document or I write a document, right? So that basically ends up, and if it completes successfully, right, that will result into a session token being created. Okay, and that session token can basically be used, right, for performing reads, or maybe if someone wants to perform a read, right, they can use that session token and can use it further, right? uh, and any sort of operation that you do, right? So the update or any updates happening to document, that will always result into a session token. So what it and also one more thing is this, right? That your documents could land into any physical partition, right? So if I have an account, right, or if I have a collection, right, and that collection could have 5 physical partitions, right? So when I'm writing a document A, right, so it might end up into the partition 1. Then I write document B, right, it will end up into again partition 1. So that session token range, right, that will be at a partition level. Okay, so maybe the document A could get a session token 1, right? The document B could get session token 2. Okay, so what I really mean to want to say here is that your session tokens are not associated to a document, but they are literally associated at a partition level. Okay, and your second partition, right, a single physical partition could have its own independent range. Okay, uh, and uh, uh, and one more thing is this, right, that you cannot think of a session token as a historical, version, right? Which you can basically use, right, to kind of go back to go back point in time, and maybe you can just replay messages. It is just a kind of a versioning that we use, and it will quickly get updated, right, as and when the new updates are coming at the physical partition level. Plus, if I there's this snap, if you can see clearly, right? Your session tokens have a certain convention, right? So, for example, if I am in a single write region, okay, so the first right number that you'll have there, right, would be a partition ID, right? So even your physical partitions are numbered, right? So maybe 0, 1, 2, 3, 4, 5, and they'll keep on evolving, right? Based on whatever backend activity happens, right? The second number that will be there, it will be the version ID, okay? And the third will be the LSN, right? So the LSN is the certain number, right, that get assigned on our backend after all after document gets correlated in and inserted into the backend, okay? In a multi-write setup, right, you would basically have a partition ID, and then you will have a hub region, right? So in a multi-master setup, right, you will always have one region which will be the hub region, which will take care of all the conflicts, right? Any sort of activities that are happening there. And then there will be a LSL, right? And then after that, you'll have a combination of regions, right? So you could have n number of regions, right? So you'll have a region, and then you'll have region version ID. So if you look at those snaps, right? So the first snap is where you have only one region is configured there. So you have 0:-1 and #11. Okay, so it is just one region which is taking care of all reads and writes. The second is an example where I have one write region and one read region, right? So there I have 0:2 #31, and #32 is the actual region ID, right? And then -1 is the ID. -1 is because the read region doesn't have any sort of a versioning, right? It is just getting replicated. And the last one is where I have a multi-write setup where I have each of this region, right? 30, I would say 5 and 11 and 2, 32, right? So all of them are having some versions, right? So whenever there's a write happening in a maybe in a third region, right? So the versioning will increase, right, for that specific region, and then it will be correlated as an LSN. So that's how the session tokens would. So whenever you're looking at your diagnostic strings, right, you'll see the session tokens, and you'll see a sequence like this. Okay. So the next thing is basically the quorum rights, right? So with respect to the quorum rights, right? So this over here, right, I have depicted. So assuming that if we have multiple regions, right? And then if we have one physical partition, let's say #1, so that #1 will have basically three other replicas, right? So one would be primary, the others will be secondaries, right? And then I could also have multiple other partitions there, right? And whenever, right? So for almost all sort of consistency levels, right, except strong, they will basically follow a local majority, right? So what that really means is that whenever you're writing something, a document, right, to a physical partition or to the Cosmos backend, so it will basically get replicated to three replicas, okay? And there will be like another replica which will take care of synchronizing that information, right, with the other regions, right? And in case of a strong consistency, it will be a global majority. So what that really means is that data will get written across regions because the data has to be consistent, right? And the reason it is going to be very expensive. So if you follow this, right, and if you are just trying to, for example, if I've written this document, right, to maybe partition 1 and maybe region #1, okay? So if I try to read from #2, there are some chances, right, that I might see some stale data, right? But if I try to read from #1, 99.99% you're going to be able to see the up-to-date information because three replicas are all almost updated. The fourth replica, I mean, would have caught up by then, right? So most of the times, you should be able to get if you're writing something, right, to a specific region, you're trying to read it from the same region, then most of the times you should be able to get up-to-date information. Unless you're trying to read from a region from a region where the write was not performed. So then there are chances that you can see some stale data. Right. Coming to Quorum reads, right? So similar setup, but then when you are actually trying to read, right, using session consistency or eventual or consistency prefix, so the data will be read from a single replica. Okay. So the reason your any sort of a reads that are performed, right? So for example, you might have configured your account using strong, but you're now reading using session consistency. So you're not going to be charged, right? Your read charges will be pretty less because you would now be your reads will be happening on a single replica. But in case if you're reading using bounded stainless or strong consistency, uh, two replicas will be used. Okay, so it will basically go and read from two replicas just to make sure the data is consistent, right? And just to make sure they're just sending out the up-to-date information, right? So your any sort of a reads that are performing strong and bounded stainless, they are going to be 2x expensive compared to eventual or consistency prefix or session. Okay. So quickly, I'll just dive into scenarios, right? So the first scenario is basically going to be read your writes. So what this really means is that once an item has been updated, the subsequent reads from the same client, right, would return the updated information, right? So now how does this translate into Cosmos, right, from a SDK standpoint? So the first scenario, right, is where we basically have a client one, maybe one JVM, right? And it is basically performing a write. And from the same JVM, right, we are basically reading it. So in that case, it's guaranteed, right, that you are going to get the up-to-date information, right? But in a second scenario, right, where you have you're writing it from a JVM one, right, and then you're trying to read from a JVM two, right? Now there are like there's this 1% chance, right, that you might get some stale data because because you might be your replicas might be lagging behind and you might not have to up-to-date information. So there's a chance, right, that the client two would basically get some stale data, right? Now, one more thing that happens here is that whenever we basically write, right, so using your SDKs, whenever you write some data, right, so the session tokens basically get cached. So when the JVM1, right, wrote something with token T1, that typically got cached. And when the same JVM tried to read the information, the same session token was passed implicitly, right? Okay, so that intelligence is baked into the SDK and it takes care of it. But in scenario two, right, when JVM1 wrote something, the JVM1 has the knowledge of token T1, but the JVM2 doesn't has any information of what that session token is, right? And it just went without a session token. And high chances that it could result into a stale data. But uh, as long as that, one more thing is this, right? As long as that request is within that region, uh, um, and given that we have this three replications or three replicas being updated, rare chances, right? If the request goes to that fourth replica and it is overburdened, then we can see stale updates. So what I really want to convey here is that uh, try to redirect your reads, right, writes and reads to the same region so that you get up to date information. All right. So this scenario, right? So here, basically, what we are talking about is like reads, right, which are happening across regions, and here we are gonna use session tokens, right? So assuming that you have two regions, okay. The region one is doing writes, and there is a region two, right, which is from where the reads are happening, correct? And this could be a classical scenario, right, of a e-commerce site or any shopping site, right, where a consumer, right, may basically place an order, right, through a mobile, right, and then maybe or someone may try to access it, right, from a different location, right, altogether, correct? So high chances, right, that they could, high chances that this could happen. And we have seen some scenarios like this, right? And they could see some stale information. Now the way, right, there are like teams that they are solving this problem, right, is basically by using session tokens, right? So what they really do here is that whenever, right, there's a write which is happening in region one, right? So what they will do is like they'll basically maintain that session token, and whenever they want to basically read, right, from that session token, for that they have for that specific ID, right, or partition key, they'll typically use that along with that session token. And what will happen in that case is like they would basically be getting the latest information that was at one point of time associated through that session token. So maybe when the data was written, right? So the session token was T1, and the region two basically passed that information, right, to for reading the data. But the region two was not up to date, right? So it might not have got replicated, right? So what would really happen here is that the request will typically wait, right, until the region gets synced up and the data is available. Okay. Or in case of session consistency, what will also happen is that the SDK will take care of fulfilling that request by sending requests out to the other region, right, or remote region, and getting the data out and fulfilling that request. So these are like some things that SDK will take care of it to basically make sure the data is available. Okay. Another thing that could happen is this, right? That the data that could have got written is T1, right? And you might have sent a request with session token T1, right? But in the meantime, someone might have again updated that information, and now your data would be available with token T2. Okay, so and if your region gets synced up, right, by that time, the region two gets the data out, right? So you could still get maybe much more latest data, right, with token T2. So that's also a possibility. Okay, so it completely depends how fast that replication happens, and you're able to get some latest information. So few things, right, that we have to keep in mind over here is that uh, whenever you're passing session tokens, and if your regions are not having that specific data for that token, it's gonna wait or it's gonna go to a remote region for it to be fulfilled. So it's going to always add up some latency for you. Okay, so I can quickly show you this, right? So maybe just let me share my terminal here. So what I'll do is I'll execute this one, right? So Java Functions. So let me run this up, right? So when I run this, what I'm doing over here is that I am basically, I have a account, right, which is set up something like this, right, where I have uh, three agents which I've configured here, right? Central US. So this is not coming out. So I have basically configured a region, right? So I have Central India, I have Australia Central, and then I have another region, right? And so if you see, right, this is my connection string here. So I'll just copy this to show you how this will look like. I'll just copy it here. So, all right, so control. This out of it. All right. I'll format this document. So if you look at this now, right, this document. So this is I performed the read operation for this, and what really happened is that I've simulated this, right. So where I send a request to for a certain partition key, right, to Central India, right, location. It basically reached out to one of the slave replicas, and the status code was 404. Okay, which means the read session was not available. Okay, the read session token was not available. Okay, and then it basically tried the session. It basically tried the on the same central region, right? It tried a second replica. Okay, the second which I was showing, right? So we have four replicas. So it tried the second one now, right? Now again, if you see this is 404, and now it has tried the third replica on central India itself, correct? And then it is still 404, and now it has tried the primary replica, okay, which is again in central India, and then finally it has gone to Australia Center, and the data is got fulfilled now, right? So if you see this, the status code is 200. So this basically correlates with the use case that I was showing, right? Where if the read session is not available, the session token is not available, your overall latency can go high. Okay, and if I just show you this, right, within the code itself, right? So with the latest SDK version, right? So we basically also have something which is available, right, where you can specify the session retry specific region switch, right? So what that really means is that, for example, if you don't have the session token available in the local region, how many times do you want to retry? You want to retry for 2 times, 3 times, 4 times, before you want a request to go to the remote region. So with the later SDK versions, you have this capability now where you can specify this. Yeah. Okay. So with this, right, I just wanted to demonstrate, right, so how that thing would work typically. Yeah. And then the similar thing is for the write request, right? So let's assume that if you are in a multi-write setup, okay, and you're not using session tokens, okay. So what could really also happen is that imagine that there are like you know two documents getting updated from multiple regions. So very high chances that one of the documents could get updated, right, or the updates could get lost, right, and the e-tag specific logic doesn't work quite well, right, with a multi-write setup. So in case you're not using session tokens, then you could see some weird behavior there, right? But the moment you use session tokens, what will happen is that you would basically wait, right? So if, for example, if the write is coming from region one, right, and the region two also wants to update the same document right now, so they will basically use the session token, right? And uh, when the region two basically tries to update the data, it will wait, right, until that session token specific data has been synced right on region two, and once it is synced, it will make sure, right, to update on top of that. So in this process, the data would not get lost, right? If there's a requirement, right, where some things like this are happening, right, which we have seen, right? So there are like some application team, right, who come to us, right, where they see such behavior, right, when they're working multi-write region setups. But the only thing over here again is that the moment you start using session tokens, again that latency specific hit you'll be getting, right? And with that, because of that replication thing to happen, right? Because we have now used the session tokens. So similar thing, but the the pros and cons of using it and not using it, right? And this is purely depends, right, app to app, how comfortable they are, right, having this thing, right? And then finally, another scenario is like where you have these query operations which are happening, right? So whenever you basically perform queries, right? So queries could typically be, restricted to a single partition, or they could be a fan outs, correct? So when I say a fan out, right, you could have 10 physical partitions, right? So the query might hit all 10 physical partitions, which is very expensive, correct? Now, in such cases, right, the SDK would have cache some session tokens for those physical partitions, right? So whenever it basically hits a query, right, so it will internally basically use the session tokens, right? So practically, whenever you are actually formulating these queries, right, you don't have an option, right, to specify session tokens at a partition level. So the SDK takes care of it, right? but you still have liberty to pass one session token. But practically, it doesn't help much, right? So SDK, that's its own intelligence, where whatever that is cached, it just puts in there, right? And you get to see the data, right, based on that session token. So that's pretty much about the query as well. Yeah. So that's pretty much I had, I wanted to present any specific questions.
Hey, thanks, Faiz. There is a question on the chat. How does Cosmos DB guarantees consistency in AEs, like availability zones?
Uh, can you repeat that?
How does Cosmos DB guarantees consistency levels in availability zones?
Yeah,
I
so
mean, is it
that is
different from?
something. No. So it is the same thing, but then you have to opt for it, right? So whenever you're actually provisioning your regions, right? So you have to just provision, or you have to just opt for it, and with some extra cost, right? Then you'll the same logic works behind the scenes, right?
Okay.
For the outage zones as well. So nothing different.
Okay. Got it. Yeah, that's all we had on the questions. Anyway, thanks a lot for the wonderful insights and also the session. And thanks, audience, for asking the questions. Before I close, make sure to subscribe the channel, and please do provide feedback if you want to hear a particular topic. We will meet again in a couple of weeks. Next time, we will be talking about something on the JS SDK. Yeah, we will go live with another guest. Thanks, Faiz.
Thank you,
Thanks,
Sujit.
everyone.
Thanks, everyone. Bye-bye.